Now let's just talk about the question number 2, which is again based on the relationship. It says find the zeros of the polynomial x square minus of 3 and hence verify the relationships between the zeros and the coefficient. So let's just start the solution of this particular question. First of all, it says find the zeros of the polynomial x square minus of 3. So let us suppose we are taking the polynomial p of x as nothing but is equal to x square minus of 3. Again, what we can say about this particular polynomial, so let us suppose we are finding out the zeros of this polynomial using an algebraic identity. What is that? As we know about an algebraic identity, which is x square minus of a square, and it can be expressible as x minus of a into x plus of a. So using this particular algebraic identity, we can able to find out the zeros of this particular quadratic polynomial as px is equal to x square minus of 3 can be expressible as x square minus root 3 whole square, because we do know that root 3 whole square is again nothing but is equal to 3. So hence at the end what we can say that using the algebraic identity x square minus of a square, we can express it into the form of x minus of a, x plus of a. Hence we can write it as x minus root 3, x plus of root of 3. So at the end p of x is nothing but is equal to x minus root 3 and x plus of root 3. So the number of zeros, or we can say the zeros, of p of x will be, p of x should be is equal to 0. It means x minus of root 3, x plus of root 3 is equal to 0. It implies that x is equal to root 3 and x is equal to minus of root 3 are the two zeros of this particular quadratic polynomial. So hence again what we can say that let alpha beta be the two zeros of the quadratic polynomial px as x square minus of 3. Now let us suppose I am taking it as ax square plus bx plus of c. By comparison, what we can say that the value of a is 1, the value of b is nothing but 0, and the value of c is nothing but minus of 3. So these are the values of the coefficients of the variable x with the different degrees. And further, what we can say, we have to verify the relationship. So we are verifying the relationship as the sum of the roots is equal to alpha plus beta. So let us suppose we are taking the alpha as nothing but root 3 and beta as nothing but minus of root 3. So alpha is root 3, beta is minus of root 3. So this will be root 3 minus root 3, which is equal to 0, and it can be expressible into the formation of minus of b by a, because we do know that b is nothing but 0 and a is nothing but 1. So we can express 0 as minus 0 by 1, which is nothing but of the form minus b by a. So at the end what we can say that alpha plus beta value is actually coming out to be equal to minus of b by a. And further the product of the roots is equal to alpha into beta, which is root 3 minus of root 3, which is minus of 3, and it can be expressible as minus of c by a. Because of we have negative, we have minus of 3, we can express it into the formation of minus of 3 divided by 1, and this is nothing but of the form c by a, that is constant divided by the coefficient of the x square. So hence at the end alpha plus beta is nothing but is equal to c by a. Hence the relationship is verified that the sum of the roots is equal to minus b by a. The product of the roots alpha beta is nothing but is equal to c by a. So this is all about verifying the relationship between the zeros and the coefficients of this quadratic polynomial.